So we're still in section 1.5. That's the last part of section 1.5. And the book decided to deal with trig functions. So when I look at inverse sine of 0.5, now they might not write that the way you see it. They might write that what? There's another way of writing that. Anyone? Remember something called arc? Arc sine? That's the same thing. So when you see the arc sine, that means the inverse. When you see the cosine, inverse cosine of 0.7, they can say the arc cosine of 0.7. Oh, I shouldn't have that -1 up there, arc sine. Arc cosine. The inverse tangent of 2, this would be written arc tan of 2. So the book decided to bring that notation here. What is the arc tan? What's the cosine? What's the sine? So let's take a few of these and see if we can get the answer to them. Arc sine of -1/2. And again, they could probably want the answer in degrees or in radian. Usually in trig, they want the answer in radian. And a lot of times it helps if you have the unit circle. If you go to Google and just type in unit circle, I might have one here. What do you know? I went to Google, I typed in unit circle, and I got that big list here. It's nice, easy to see. Well, we're asking you which or what angle has a sine of -1/2. Well, I can minimize what I'm looking at. I don't want to waste my time. There's too many of them. So we all use what? All students, yep, take calculus. When I'm teaching tech math, I don't use this because they don't take calculus. I use all stores take cash. Anything you want to. All students try chicken. It's fine. I don't care what you want to use. But what that tells you, all of them, the sine, I just deal with the first three. Cosine, tangent, all positive here in this quadrant. Out of the three, which one begins with the letter S? Only the sine. Sine is positive. Cosine is negative. Tangent is negative. Sine, cosine, tangent. Here, which one begins with T? The tangent is positive, negative, and negative. This one, sine, cosine, tangent. Cosine is positive, the other two are negative. So it'll let you know where the positive, which one is positive. So here we have an angle that's a -1/2. That tells me sine is negative. Don't waste your time looking in the top half. The sine is positive here and here. So only look right here. So if I look at that, bring my unit circle back, the sine is the second number on this chart. Where's the second number -1/2? 7 pi over 6, or where? 11 pi over 6. So the answer to this is 7 pi over 6 or 11 pi over 6. If we said arctan what angle has a tangent of the square root of 3? The tangent. And it's positive. Tangent's positive where? The first quadrant and the second quadrant. I mean, third quadrant. First and third. That's where the tangent is positive. So when I'm looking at the unit circle, I'm going to be looking at the first and the third quadrant. Now, the unit circle doesn't have a tangent on it. There's no tangents, only cosine and sine. Well, the tangent is what? It's also sine divided by cosine. That's what tangent is. So if you look at this one, if you divided the sine by the cosine here, the square root of 3 over 2 divided by 1 over 2, guess what you're going to have? This will be the root of 3. If I divided this by this, you're going to have what? 1. That's not it. If I divided this by this, what am I going to have? 1 over the square root of 3. They want it to be what? The square root of 3. What's the answer? Pi over 3. And where's the other one? I bet you right here. If you divided this, negative over negative, that's positive. This is 1. Negative over negative, that's positive. So where's the tangent equals the square root of 3? Pi over 3 and 4 pi over 3. So you can actually go through these, divide the sine by the cosine, get the tangent for each one of these. So you'll have them all in front of you. Now this is the fun stuff here. It's to solve this equation. Arc tan 2x minus 3 equals pi over 4. They want us to solve this for x. Solve for x. Arctan, that's the inverse tan. One of the best ways to cancel the arctan is what? You take the tan of both sides. The tan of arctan equals the tan, so I'm taking the tan of both sides, pi over 4. The tan and the arctan, one is the inverse of the other. Going back to this equation, we said if you take, where did I write that? A few minutes ago. If you take the function of the inverse of a cat, you get the cat. If you take the inverse of the function of the cat, you still get the cat. Well, these two are the inverse of each other. So if you do that, the tan and the arctan are going to cancel each other, and that's your cat, the 2x minus 3. So this will cancel that. You end up with 2x minus 3 equals the tangent of pi over 4. Let me go to pi over 4 and see what the tangent of pi over 4. I just did that. That's what? 1? From my unit circle, take the minus 3 there. We have 2x equals what? 4, x equals to 2. Let me try another one. Another crazy one. I'll go a new sheet with it. I need to save these so I don't forget about them. Given y equals arc sine of x, and it says where y is between 0 and pi over 2, and the question, find the cosine of y. Fun stuff. Find the cosine of y. What the first one is saying, arc sine x, we have an angle. The sine of that angle is equal to y. So if you graph it, that's what the statement. Let's look at this. Y equals arc sine of x. So if I graph it, they're talking about first quadrant here, so I'm going to stick in the angle in the first quadrant. There's an angle here, y, in the first quadrant, and the sine of it is equal to y. The sine of it. Another way, if you don't see it, I'll put it this way. Let's take the sine of both sides, because that arc sine might be giving you a hard time. And what happens here? You end up with sine y equals what? Isn't it x? If you do the math. So I took this statement that says y equals arc sine of x, and I say, you know what? Let me take the sine of both sides. So now that tells me sine of y equals x. Well, the sine is what? The opposite over the hypotenuse. That means this will have to be what? X, and this will have to be 1. What is the sine of this, using this trig here? Opposite divided by the hypotenuse. Remember that from trig? SOHCAHTOA, in case you forgot. What's SOHCAHTOA? The sine equals opposite over what? Hypotenuse. The cosine equals what? A for adjacent over the hypotenuse, and the tangent equals O over A, opposite over adjacent. These are the basic trig functions, sine, cosine, tangent. It says the sine equals x. That means the x is x over 1. This has to be the opposite. That has to be the hypotenuse. Now, if you use Pythagorean's theorem, it says a squared plus b squared equals what? C squared. That means this side here has to be 1 minus x squared. It has to be. Why? A, b, and c. C squared equals a squared plus b squared. C is 1 squared, that's still a 1. A is unknown. B is x squared, bring it to this side, which means a equals the square root of 1 minus x squared. And that's why I wrote there. And once you have that side, to answer the question, find the cosine, you're done. What is cosine y? Cosine is what? The adjacent over the hypotenuse. What is your adjacent equal to from that picture? 1 minus x squared. And what is the hypotenuse? 1. And that's what cosine y is.